Hello everyone, welcome again to MISIAN online lectures, and today we are going to solve a question here, and the question is from circuits analysis. Without wasting time, the question is asking us to find the voltage V1 and V2 in the circuit given here. Please feel free to pause this video and try to see whether you can get the same answers. We are going to solve this question together. When you are given this kind of question, you have to know, first of all, remember Ohm's law, which says the voltage V equals to current times resistance. So you must remember this always in circuits, otherwise it's gonna be a problem to you, or life is going to be very difficult to you in dealing with circuits. So Ohm's law is everywhere and it's applied everywhere in circuits. This question is a little bit advanced for college levels, and those who can manage to solve it, please feel free and try it, and give also comments on the comment section below with your answer or with other ways of doing it. With this kind of question, we are going to use actually one law here from the guy called, or the law called Kirchhoff's law of current. What does Kirchhoff's law says? There is this guy called Kirchhoff's law. This is a physicist, or is an engineer who developed a law which helps us to solve this kind of circuits when we are analyzing them in terms of current and voltage. So Kirchhoff's law developed two laws. One, we call it KVL, Kirchhoff's voltage law, which states that the current, the summation or the algebraic sum of voltage across a closed loop should be equal to 0. For instance, for this loop here, this box here, we call it a loop. So if we move around here, find the voltage across this, going across this loop, the sum of voltage here should be equal to 0, same as this one and this loop. That is KVL, or Kirchhoff's voltage law. The other one we are going to use now here in this case is called KCL, Kirchhoff's current law. This says the sum of all current entering a node. A node is an uninterrupted segment of a wire which is considered to be ideal. Ideal meaning is actually, or it does not have a resistance. So the summation, or the algebraic sum of all the currents entering a node must be equal to 0. So for this law, we are going to apply here KCL, because we want voltage across these nodes V1 and V2, voltage V1 and V2. So I think we have devised about this law. So we are going to use KCL, which is Kirchhoff's current law, and we'll start. This is a node 1, node 2, or V1, V2. So we can say node 1 or node V1, V1. We can start by there. We want to know the current flowing to this node. From Ohm's law, current is given by I equals to V over R. Current is given by V over R, which is current is I, V is voltage, R is resistance. So V is the voltage at this node, and we have the source voltage of 45 flowing this way. So the difference in voltage is the one actually is that's the amount of voltage or the which passed through 500 ohm resistor. So what is the difference of the two voltage will be V1 minus 45 divided by 500 ohm. That's the current going through the 500 ohm resistor from the given equation here. Next, we have 1 kilo ohm resistor. 1 kilo ohm resistor meaning is 1 times 1,000, which is 1,000 ohms. From Ohm's law, you know resistance is measured by ohms, which is actually this symbol. But when you conversion purposes, when you have 1,000 ohms, is equivalent to 1 kilo ohm. So this is the conversion rate we are going to use here. So this is the current coming or passing through here to V1, plus now the current around passing through 1 kilo ohm resistor will be V1 divided by 1 kilo ohm, which is V1 divided by 1,000, plus the current now passing through 2 kilo ohm resistor will be the difference of V1 and V2, which will be V1 minus V2, V1 minus V2 divided by 2,000 ohms. Then all that will be equal to 0. Let's see. We have V1, V2. We can put V1s together and V2 together. So we will have something like this will be V1. Let's factor out V1 into here we'll have 1 over 500 plus 1 over 1,000 plus 1 over 2,000. This is V1. I just split this. This is the same as V1 over 500 minus 45 over 500. So this will be minus now V2 into 1 over 2,000. Then the lastly will be equal to, this was minus 445 over 500. So when it crosses over, the equal sign becomes 45 over 500. So let's see. Allow me to use a calculator here so that to save time. This is something you can add this together and see what you get here. That's 1 over 500 plus 1 over 1000 plus 1 over 2000. Okay, you will get this will be 3.5 times 10 minus 3 V1, then minus the reciprocal of that, let's say, divided by, be sure, this is the same as 5 times 10 minus 4 V2 equals to 45 by 500, 0.09. This is question 1. We are going to solve this. So the next part here, we are going to solve is for node 2. So let's call this node V2. For node V2, let's see. We are going also to apply KCL. The current coming to this point, or when we sum it together, should be equal to 0. So we start from current flowing through a 2 kilo ohm resistor here to this one, and also the current flowing through 200 kilo ohm resistors, and also this current coming there. So what we do here, we have to get the difference now. The difference now will be, this is the final V2 minus V1. So it will be V2 minus V1 divided by 2000 plus, let's see, plus the current now coming is this one, plus V delta over 750, and if we look at this, it will be also plus V2 divided by 200 plus V2 divided by 200 ohms. This will be equal to 0 as per KCL law. So we'll do the same here. We can put V2 and V1, separate them. But before we do that, if we consider this circuit, let's look at this. There is current flowing from here to node V1, and also the voltage across this resistor, 1 kilo ohm resistor, is V delta. And this V delta, which is the voltage across 1 kilo ohm resistor, is also V delta here. So what does that mean? V delta is the same current which is V1 here. So from the circuit here, from the circuit, we know V delta is equals to V1. So since we have known V delta as V1 from here, we can take this V delta which is equal to V1. Instead of V delta, we put V1 now here at this as V delta. So we can replace this with V1. So since we have done that, we can now make a second simultaneous equation here. Now we'll be having minus, let's say we'll be having minus V1 into 1 over 2000. Let me write legibly. So this will be equal actually to, we can say V1 into minus 1 over 2000 plus 1 over 750, then this ends there, then plus V2 into 1 over 2000 plus 1 over 200, everything equals to 0. Now if we add this together, actually we can make a question so fast here, simplify it. Minus 1 divided by this is, so this is actually you'll have minus 1.83 times 10 minus 3 V1 plus 1 plus 1 over 200, which is 5.5 times 10 minus 3 V2 is equals to 0. Now we have the second equation. This is the second equation here. So if we consider we have two simultaneous equations here, equation 1 and 2. Now what we can do, we can solve this excuse me, simultaneously, graphically, or whichever matrix method, whichever method works for you best, so that we can get V1 and also V2. For me, I think I can do with my calculator because I can type all the equation in. But I can show you first before I get the final answer. We can use actual substitution method here, whereby I can make V1 the subject of the formula, whereby I would say V1 would be equals to 0.09. This goes the other side, becomes plus 5 times 10 minus 4 V2 divided by 3.5 times 10 minus 3. So you take this, the value of V1 here, wherever in equation 2, substitute in equation 2 here. Wherever you see V1, put this value, the whole of this there, and solve. So if I put V1 here, which is this one, I'll have actually only V2 in the whole equation. So that let me put here actually that equation so that I can be able to get direct V1 and V2, but that is the way you get. For instance, if you get, I can give you an example. Let's say you get you get the value of V2 first here, which will be equal, let's say 2 volts. You will now come back with the 2 volts here. Wherever you see here V2 here, so instead of V2, put 2 here. So it will be 0.9 plus 5 times 10 negative 2 times 2 divided by this. You get the value of V1. Now let's let me get the correct value so that we can confirm. We have V1 here. Okay. As for your understanding, there are some gadgets here actually for advanced level. This calculator is capable of actually solving this simultaneous equation and giving you the answer in terms of matrix form. So okay, so here it gives me V1 here. From here we get V1 equals to 27 volts. V2 equals to 9 volts. So this is actually the node of voltage V1 and V2 as per the given circuits. For if you want to prove, please take this value in this equation, actually the way they are. In V1, just replace with 27 and just do some math here. You will sum everything and you will get the answer equal to 0. Same with this one. Instead of V1 here, substitute the value of V1 and V2 here, you will get the answer 0.9, and that, if it satisfies the question, those will be the correct values for this question. Thank you for watching, and please feel free to share and give a thumbs up in this presentation. Next time we are going actually